You've seen them, right? If you've spent any time online in the last, decade or so, you've seen those videos. Robots running through the woods, jumping over obstacles, even doing backflips. But behind every single one of those viral moments is a 4-decade-long quest, led by one visionary founder, Mark Raibert. This is the story of how he taught machines to move just like animals. Now, this might sound a little backward, but this was the guiding principle at Boston Dynamics from day one. See, while the rest of the robotics world was focused on building these slow, super careful, stable machines, Mark Raibert wanted to do the exact opposite. He wanted to build robots that were aggressive, dynamic, and always on the very edge of falling over, because he believed that's where the real magic of movement actually happens. And it all really started with this aha moment. Raybort's at a conference, and he sees this 6-legged robot that moves so slowly. It was always keeping at least 3 feet planted on the ground, for stability. It looked less like an animal and more like a moving table. And right then, he realized this entire approach was just fundamentally wrong. He had to do the complete opposite. So what we're talking about here is a total flip in how you think about robots. Traditional robotics, it played it safe. It was all about static stability, never ever falling. Raybert's vision, it was straight out of biology. He knew that the way animals and people actually move isn't about being cautious. It's about constantly, actively balancing, using the spring in our step, and literally flying through the air from one foot to the next.
So, how do you get money for a wild idea like this? Well, Raibert and his mentor, the legendary Ivan Sutherland, they just walk into DARPA's offices, pop open a Samsonite suitcase, and pull out the skeleton of a one-legged hopping robot. And the program manager, he was so excited he got them $250,000 on the spot. And just like that, the pogo stick robot was born.
Okay, so how in the world does a robot with one leg actually balance? Well, it turns out it's based on 3 kind of surprisingly elegant principles. First, you have to control the energy in each hop to manage how high it bounces. Second, you calculate exactly where to put that foot down to stay balanced. And third, you apply a little bit of torque to keep the body upright. That's it. Those 3 simple ideas were the key that unlocked dynamic movement.
All right. Mastering balance inside a controlled lab, that's one thing. But the next great challenge was to cut the cord. It was finally time to take these incredible machines out of the lab and throw them into the chaos of the real world. Mud, rocks, hills, the whole shebang.
And the technological leap here was just enormous. I mean, the early lab robots back in the 80s were literally tethered to computers and hydraulic pumps the size of a room. Fast forward to the early 2000s, and Boston Dynamics creates Big Dog, a completely self-contained robot with its own gas engine, its own computer, its own power. For the very first time, a dynamic robot could actually go explore the great outdoors. This became another one of the team's core mottos. They just weren't afraid of failure. They would spend countless hours hiking with Big Dog on these rugged trails, pushing it until it broke, and then they'd just fix it and make it stronger. This kind of relentless real-world testing was the only way they could build a machine that could handle how unpredictable the world is.
And the results? They were just astonishing. Big Dog's successor was a robot called LS3, and it was designed to carry a 400-pound load for soldiers. But just to see what it could do, the team once had it carry over 1,000 pounds. That's like one robot carrying another robot on its back. Incredible. But the next evolution, it wasn't about getting bigger or stronger. It was about becoming more approachable. Big Dog was an absolute beast for sure, but it was also loud and, let's be honest, kind of intimidating. If they ever wanted a robot that could work alongside people in offices or homes, they needed a whole new design.
And do you know where the inspiration came from? A simple question. After Google bought Boston Dynamics, co-founder Larry Page just asked Raibert, could you make a smaller one that wouldn't be so intimidating in a house? And that single question, that's what sparked the creation of Spot, the sleek, quiet robot we all know today.
So this was a huge engineering pivot. They went from a loud, gas-powered engine and messy hydraulics to a quiet, battery-powered, all-electric system. But it wasn't just a technical change, it was a business one too. This was the moment they transitioned from a rugged, government-funded research project to a refined, commercially viable product, one that could work in warehouses, on construction sites, and even out in public. Okay, so after 4 decades of completely mastering the body, Mark Raibert has turned to the next great challenge for his new AI institute, giving robots a mind. He's already figured out how to make them move. Now he wants to make them think. Raibert basically breaks intelligence into 2 parts. The first one is what he calls athletic intelligence. This is everything we've been talking about, right? The mastery of balance, of movement, of physical control that makes these robots seem so alive. And let's be clear, Boston Dynamics has basically set the world standard for this.
But then there's the second part, cognitive intelligence. This is the ability to understand the world, to make plans, to learn from experience. It's what goes on inside our heads, and it's something that most robots today are completely missing. This is the next great mountain for the entire field of robotics to climb.
The ultimate goal here, it sounds like something straight out of science fiction. On-the-job training for robots. The dream is to create a machine that can just watch a person do a task, actually understand the goal, and then figure out for itself how to do that same task. This would be the true fusion of body and mind.
So after this incredible 40-year journey, the big question is still out there. We've seen these robots master movement in ways that are beautiful and frankly astonishing. But the next, and maybe the final frontier, is cognition. The question isn't just if they'll learn to think, but maybe what they'll think when they finally do.